For pretty much all of human history, a city on the moon, that was pure fantasy, right? Just the stuff of novels and movies. But what if I told you that reality is finally catching up, and it's catching up fast? What was once science fiction is now becoming a serious engineering and economic blueprint for our future. So, let's break down how.
So, which one is it? Is this just a grand vision, a dream we'll never reach? Or are we genuinely standing on the edge of our next great reality? Well, in this explainer, we're going to get into the why, the how, and the absolutely incredible challenges of building humanity's very first city off-world.
All right, first things first. The big question. Why even do this? Why go all the way back to the moon just to build a city? Turns out, it's not just about planting a flag this time. There are some incredibly powerful strategic reasons driving this whole new space race.
Yeah, the reasons really start to stack up when you look at it. For scientists, the moon is just this perfect, pristine laboratory. No atmosphere means our telescopes could get a view of the universe like we've never seen before. For the economy, it's a treasure trove of resources. And strategically, it's the perfect training ground and launchpad for going to Mars. But maybe, just maybe, the most important reason is that it's our ultimate insurance policy. It's about giving humanity a second home.
Okay, but the real economic game changer is water. Yep, water. We've confirmed there's water ice in those permanently shadowed craters at the poles, and that is the holy grail. Why? Well, think about it. Water is H2O. You can split it into hydrogen and oxygen, which are the two main ingredients for rocket fuel. A base on the moon could become a cosmic gas station, refueling rockets heading out into deep space, making every mission cheaper and way more ambitious than we can even imagine today.
All right, so the dream is big, it's compelling. But the reality? Well, the reality is incredibly harsh. The moon is not a friendly place. Not at all. And trying to survive there means facing down life-threatening dangers every single second of every single day.
This chart really says it all, doesn't it? Here on Earth, we're cozy. We live under this thick, protective blanket of an atmosphere, and we're shielded by a powerful magnetic field. The moon? It has neither of those things. That means there's nothing to stop lethal radiation from the sun and deep space, nothing to burn up incoming micrometeorites, and nothing to keep the temperature stable. It is, quite literally, one of the most hostile environments we could possibly go to.
And speaking of temperature, let's just focus on this number for a second. 270 degrees Celsius. That's the total swing in temperature. So in the sunlight, it can get way hotter than boiling, over 100 degrees. But the moment you're in the dark, it plunges to a mind-numbing minus 170. Just imagine trying to build anything that can survive that kind of whiplash.
And the dangers are just relentless. You've got this constant bath of cosmic rays, plus these sudden violent solar storms that could be deadly. The very ground you walk on, the regolith, is this fine, electrostatically charged dust that's as abrasive as tiny shards of glass. It gets into everything, shredding spacesuits, clogging equipment, and it's terrible for your lungs. Top that off with a perfect vacuum and a constant shower of tiny bullet-fast micrometeorites, and just staying alive becomes this monumental task.
But here's the thing. For every single one of those challenges, human ingenuity is coming up with a solution. This isn't about fighting the moon's environment head-on, it's about learning to live with it, using a whole new toolkit of amazing technologies.
And this right here is the single most important concept that makes a lunar city even remotely possible. It's called ISRU. And all it really means is using what's already there. Because think about it, launching every single brick, every tool, every drop of water from Earth, it's just not going to happen. It's way too expensive. The only way we can build a city is if we learn to live off the lunar land.
Which of course leads to the most basic problem of all. If you can't ship your building materials 240,000 miles through space, how in the world do you build anything? Well, the answer is one of the coolest technologies in development right now.
You 3D print it with moon dust. I mean, just imagine this. Swarms of robots scooping up that nasty regolith, feeding it into a printer that uses focused sunlight, basically a giant magnifying glass, to melt the dust into a solid ceramic-like material. And then, layer by painstaking layer, it builds up walls, landing pads, radiation shields, everything. That is how you build a city. And the survival toolkit just keeps getting better. We can use natural lava tubes, these huge underground caves, for instant protection from radiation and meteorites. For power, especially during that 2-week-long lunar night when solar is useless, you need compact nuclear reactors. And of course, it all comes back to those robots, working 24/7 to mine that precious water ice.
So, look, this isn't going to happen overnight. Of course not. Building a city is a multi-generational project.
It's going to happen in phases, starting small and then growing with every new success.
And we can already see the roadmap taking shape. We're kind of in the first phase right now, with all the robotic scouts. The next step is small, temporary human outposts. From there, the giant leap is a permanent base, where the whole focus is mastering that living off the land idea. Once that's done, you expand. You build specialized zones for industry and science, until, maybe by the end of the century, you could have a truly self-sufficient city with a real diverse population.
When you put all the pieces together, the reasons why, the massive challenges, and these incredible solutions, you start to realize this is about so much more than just an engineering project. This is a fundamental step in our evolution as a species.
And that's really the core takeaway here. The pieces are all starting to fall into place. All these amazing advances in robotics, in 3D printing, in reusable rockets, they're all coming together to make this vision a real, tangible thing. It's not really a matter of if anymore, it's just a matter of when.
But that leaves us with one final and, maybe the most important question of all. The technological problems are huge, but we can see a path to solving them. The bigger challenge might just be us, the societal challenge. As we start laying those first foundations on the moon, what rule book do we follow? Is it going to be a cooperative venture for all humankind, kind of like the Antarctic Treaty? Or is it going to be a cosmic gold rush, a Wild West, where nations and corporations stake claims? Deciding who owns the moon's resources and what laws will govern this new society, that might be the real next frontier we have to cross.